So a Box-Whisker plot is used to make comparisons between samples. And it has some unique features because it helps us identify or determining skew. You can determine the variation of data. Determining outliers. All of those can be achieved using Box-Whisker plots. Now, in order to create a Box-Whisker plot, we need 5 numbers. There are 5 statistics: the minimum, the first quartile, the second quartile, the third quartile, and the maximum. So P25, P50, or the median, and P75. So those 5 numbers collectively is called the 5-number summary. And one can obtain a Box-Whisker plot using a 5-number summary. So here is an example where we have 2 samples. One is X, the other is Y. What you see here is a Box-Whisker plot. So that is the box part, and those are the whiskers, hence the name Box-Whisker. So for variable X, we want to find the median. We know the 5-number summaries, so that should correspond to the minimum. That edge would correspond to Q1. That should correspond to Q2, which is the median. That edge would correspond to Q3, and that would be the maximum. So I am going to approximate the median of variable X. So I'm just going to draw a line, and I would say approximately 40, because Q2 is the median. We want to look at the variable Y in part B and identify the third quartile. So for Y, the first edge there is the minimum. That is Q1. The middle line should be Q2. That is Q3, and that should correspond to the maximum. So if I drew a line right there, that's approximately 55 for Q3. So if you have any confusion, you can always, keep this as a reference. For any data set, the box is drawn between Okay. So it's drawn between Q1, Q2, and Q3. The whiskers are drawn on either side, and hence the name Box-Whisker. So that's exactly what I'm doing in my example. So I drew a line from Q3 for variable y, and it hits the value 55. Now, which variable has more dispersion? So variable y has more dispersion because it has longer whiskers. So you can look at the range of values. The length of the whiskers is pretty long for variable y. But variable x, it's on a very narrow range. So variable y has more dispersion. And also the IQR the box width is higher for variable y. Now, part D, we want to describe the shape of the variable x. Now, if you look at it, the box and the whiskers are pretty symmetric. The box is symmetric. Balanced whisker size or whisker length. All of this would imply that there is no skew in the data. In general, if you have a Box-Whisker plot of that sort, which is balanced whisker length, approximately, then we have no skew. If it's lopsided, it's unbalanced whiskers, so that's positive skew or right skew. Likewise, if we had something of this sort, that would be negative skew. So symmetric box, balanced whisker length, then we would say that there is no skew. The shape of the variable y. So as I mentioned in part D, if you look at the variable y, the Box-Whisker plot has unbalanced length. There's a longer whisker on the right-hand side and a shorter whisker on the left-hand side. So it is right skewed. And specifically, it's longer whisker on the right. So here is an example which talks about the age of a mother at birth. So we looked at 30 mothers and we want to know when they gave birth, and we want to see if there is, if we can get any information from the sample that we have. So first up, we need the quartiles. So we can use a calculator for this. So 21. Okay, double check the data. Okay, so we want to construct a box plot. So second mode to exit. So all we need here to construct a box plot or a Box-Whisker plot is the minimum, which is 16, the first quartile, 20, second quartile, 23.5, third quartile, 26, maximum, 35. So 0, 5, 10, 15, 20, 25, 30, 35, 40. So that would be the age. So the minimum is 16. So I'm going to draw a line there. First quartile, 20. Second quartile, 23.5, perhaps right there. Q3 is 26. And we have 35. So by the looks of it, we have a symmetric box, but on one side, the whisker is quite long compared to the other side. So the distance here is about 4 on this side, the left-hand side, and it's significantly lengthier. It's about 9 on the right-hand side. So it's not perfectly symmetric. So the shape is not perfectly symmetric. And it is most likely to be right skewed. Because it has a longer length on the right-hand side. Again, this becomes very clear with larger samples, but we only have a small sample in this case. So here are the weights of M&Ms, and I've already entered the data in my list. So we're going to construct a box and whisker plot, then I'm going to show you how to do this using the calculator as well. So all we need is the 5 numbers, and the weights are between 0 and 1, and specifically it's between somewhere around 0.8 and 0.9. So I'm just going to start the scale at 0.78, 0.8, 0.82, 0.84, 0.86, 0.88, 0.9, 0.92, 0.94, running out of space, 0.96. I'll just say 0 somewhere over there. So the minimum value is about 0.79. The first quartile is 0.85. The median is 0.875, 0.9, and the maximum is 0.95. So that looks pretty symmetric to me. On the left-hand side, it's about 0.5, right hand side 0.5, equal lengths. You may think, oh, it doesn't look symmetric because I'm just a bad artist. That's all, but it is symmetric. So Q1 is right here. Minimum is right there, Q1, Q2, Q3, and maximum. You could get this using the calculator also. But before you do that, you have to set the window. So I'm going to set the window between 0, 0.5 and 1. Go to start plot, second y equals, select 1, turn it on, and go to that option, which is a box plot, and it says list 1, and hit graph. There it is. And you can see the calculator did a much better job, and you can see that the box is relatively symmetric. So we have symmetric box, balanced whiskers, which would imply symmetric distribution. Now, if we had gone for a bell curve, a histogram instead of a Box-Whisker plot, we would actually see a symmetric distribution, a bell curve per se. So if I use a typical histogram, have to adjust the window, scale 5. Whoa. Still, we have a lot of observations, so. And you can see it's not the best symmetric distribution, but it's relatively symmetric. So if we did a histogram, we would see that we have a symmetric distribution. So you can identify the shape of the distribution either using a Box-Whisker plot or a histogram. Box-Whisker plots are used in business and economics and most social sciences. In the sciences, people usually use both histogram as well as Box-Whisker plots.